Okay, another method when substitution doesn't work is to integrate by parts. Okay, so first example, if I were to create a u, right, usually with e we do eu du, then I would call this u up here, and du would be 5, right, not 5x. So we're going to fail because I have nothing to do with this x. Let's look at it really quick, but I'm forewarning you it's going to be a fail. So if I did u is 5x, du is 5dx. And so I need a 5 here, right, times by 5, and then 1/5. And when I go to make this substitution, I'd have eu, the 5 in the dx is du, but I still have an x there. Okay, you cannot integrate when we have several variables like this, you know, x's and u's, unless I know it's a double integral or that x is a constant. You know, more information would have to be given, but you can't just mix up these u's and other variables like that. Oopsie. So, moving forward, I'm gonna have to rewrite this. Okay. So, let me first explain how integration by parts works. We have, so it's a different u than the last video. Is a substitution, right? We let u and then we found du. We're still going to need du, but let me first explain. We have two pieces of this integral. I'm going to say u and v, right? We have x and we have e to the 5x. And so let's go and write that over here as we go. V is, sorry, we're going to do dv, and that'll make sense in a minute. Okay. So when I go to integrate a combination of function here, product of two functions uv, I will need to think backwards of derivative. And with derivative, we have product rule, u prime v plus uv prime. Okay, and then as I was saying, integral will undo derivative, right? So if I integrate both sides, this is kind of just a way to memorize this, like if you get stuck. So then it says uv equals, anywhere I have a prime, I'm going to go and write du. Okay, so I'd have integral of du, right, v times du plus u times dv. And it really doesn't matter which one we say is u, which one we say is du, but the idea is that most commonly used is we solve for this, and that means that the integral of u dv is uv minus integral of v du. Okay, this is the formula for integration by parts. So with that said, I had u here and dv here. If I call this u and this dv, I can now apply this integral, right, of u dv is equivalent to this. So now, which one do you make u, which one do you make dv? Well, that comes with practice, but usually your dv will, if there's an e, like these three examples have, your dv will be the e part. Okay, your u will be the other part. And the reason is we want to minimize the work here, and when we go to do du, this just becomes 1, right? So 1 times dx. The second part here is a bit tricky. Again, I don't always write it because we know after practice what we're doing, but this is a derivative, which means to get v, I got to do its integral, right? So v is going to be e to the 5x, and then when we integrate, we divide by that 5 up here, right? We divide by the constant, so, or 1/5. Remember that the integral of e to the kx, so some constant k, is e to the kx over k. All right, that's an old rule that we had learned. All right, The reason it's set up this way as well is it kind of makes for a quick memorization technique. You do u du, and then you go backwards dvv, and the formula only needs this and this minus this times this, right? So you're going u times v minus v du integral. Again, I wrote the formula over here so we could reference it. So therefore, that original integral of u dv is uv, so x times 1/5 e to the 5x minus integral v du, 1/5 e to the 5x, and du is just dx. Again, we use this u and v and dv and whatnot, and we got right back to x's, right? This problem now has all x's, we're good to go. Not really much we could do with uv here. I mean, you could write it as x over 5 if you want, but all I'm going to do is change the order just because constants are more common out front. Now the integral of this guy, I mean, we just did an integral of e to the 5x, right? We did integral of that, so let's just remove the 1/5. And this often comes up. You'll do dv, you have to do its integral anyways, and then you get the same result. So this part here, right, we just got is this. So the integral of e to the 5x is 1/5 e to the 5x. Now plus c, because we didn't do a definite integral, and we still have this minus 1/5, and we still have that front part. This may be the most challenging section of the quarter. Okay, once you get the hang of it, not bad, but it's not easy. Okay, integration by parts is not easy. Going through Calc 1, as ugly as those derivatives were, they're manageable. Integration is a whole nother field to play in. Okay, so I don't mind, if you just said combine these two, make it negative 1/25. Usually we try to factor. With this plus c, I don't know. I think this answer is perfectly fine. Okay. It would be acceptable to, so I'll say or, factor out that, and we're left with an x minus 1/5 plus c, right? Because we factored out e to the 5x here and here, and then we factored out this 1/5 here, here. So what do we have left? We have an x and a minus 1/5. All right. I put up this next example from the last video. This is actually u substitution. I have, right, if I make that u, then I'd have du here if I put a 2. But I want to show you that, always try u substitution first. If it works, great. But integration by parts, if you give it a shot, it may fail. Right? This is a good case of this. So using what we had just done, we'll make ux dv e to the x squared. And one minor thing. When we integrate, I need a dx here, right? I can't just integral without knowing what variable we're doing. It's minor, but still it should be there. So du is just 1 dx. But v now, if I'm integrating this, we don't have a way to do that. I cannot integrate e to the x squared by hand. So we get stuck. So this is why my suggestion is always try u substitution first, because it'll be quicker. A little easier to do, but if you're getting nowhere, by parts is probably the answer. Okay. I'm not going to go through it with u substitution because I created a video of this result, but I did want to share why when integration by parts work here. Okay. All right. Following suit from the first example, we're going to go ahead and let dv be the ex dx part. Okay, and make u the x squared part. It's a good rule of thumb. Maybe not 100% of the time is that accurate or the only way to do it, but can't think of a time when it doesn't work off the top of my head. Okay, so u is x squared, du 2x dx. dv is e to the x dx. Okay, so the integral of that, well, the integral of e to the x is just e to the x. Notice I didn't put the plus c yet, and that's because this formula has another integral, right? So when I go to integrate that, if I'm not doing a definite integral, I'm going to need the plus c anyways. So for this step, it's kind of redundant. I don't need to say a constant plus another constant. It's still a constant. Okay, formula says uv minus v du. So this results in x squared times e to the x minus integral v du. So e to the x times 2x dx. Well, x squared e to the x, we can't do anything with that. But notice this integral, it's fairly similar to the first example. I had to do this by parts, right? Like I said, this section is not easy. Take some practice, but we're gonna have to do by parts again, it looks like. Now this 2, it's up to you. You could just pull it out if you want. I'll go ahead and leave it, it's there. So following suit, u is going to be the 2x, dv is going to be the ex dx. du is just 2 dx. And v, well, integral v to the x, still e to the x. Okay. So the formula says, again, for this part only, uv minus v du. So that front, let's just, oops, e to the x. Let's just leave it alone. Minus, now it's subtract the whole thing. This is a very common mistake, and that'd be very frustrating to do all this work and forget to distribute a negative. So I'm going to take care of it by doing that. Okay, it's minus this whole result. Let's switch colors. So uv 2x e to the x minus integral v du. So minus e to the x times 2 dx. Okay, get ready to use some paper when you do these. So I think at this point, let's go ahead and distribute that negative x squared e to the x minus 2x e to the x, and then minus, I'm going to pull out the 2 integral e to the x dx. Right, it's just a constant, it could come out. The end is near. Integral of e to the x dx is just e to the x. Remember your plus c. Okay, that is it. That's the answer. Again, if you want to factor, if MyMathLab's being picky, factor out an e to the x. We're left with x squared minus 2x minus 2. And we still have that plus